Today we start a unit on stoichiometry. Stoichiometry is a hard to say word, it's hard to spell word, and it looks like it's something really complicated. And a lot of students are scared off by that, but really it's quite easy. Stoichiometry is really just applying what you already know about using proportions to solve problems involving counting atoms or molecules or ions in equations or in formulae. One type of stoichiometry we've already been working with a bit. It's called composition stoichiometry, and this has to do with the ratios of atoms of elements in a compound. For example, in carbon dioxide, composition stoichiometry would show that there are, for example, 2 atoms of oxygen in every 1 molecule of CO2. Or it would also show that there are 2 moles of oxygen atoms in 1 mole of CO2 molecules. So if that's composition stoichiometry, you're fairly used to that. You've seen that before. Reaction stoichiometry we haven't worked very much with, although you did see a problem or two so far. This has to do with the ratio of atoms or molecules or formula units involved in chemical reactions. So when substances react with one another, how do they go together? There are ratios involved there too. Where we get these ratios are from the balanced chemical equations. If we look at the coefficients on substances when the equations are balanced, we find that they provide us with some what are called stoichiometric equivalencies, or another name that these go by is mole ratios. For example, if we look at this balanced chemical equation, we can pull out a number of stoichiometric equivalencies by looking at the substances involved and the coefficients on those substances. Here's one. 3 moles of NaOH is the stoichiometric equivalent of 1 mole of H3PO4. And we get that from looking at the coefficients. 3 in front of NaOH, and a 1 is implied in front of the phosphoric acid, or H3PO4. You can get other ones. For example, 3 moles NaOH is the equivalent of 1 mole Na3PO4, sodium phosphate. Or 3 moles NaOH is the stoichiometric equivalent of 3 moles of water. And you could get more by just comparing different substances. It's easy to see where this comes from. The numbers in front of the substances are the coefficients in front of the substances in the balanced chemical reaction. Now you can use these mole ratios or stoichiometric equivalencies as factors in the factor label method, or as conversions in the dimensional analysis method. You could also use them in proportions, but I think that's inefficient, and you're going to see me using the factor label method or dimensional analysis more often to solve these stoichiometry problems. Like this one. This is asking how many moles of sulfuric acid, that's the H2SO4 here, that's sulfuric acid, how many moles of that would react with 0.366 moles of NaOH if this reaction took place like is shown here. Well, I'm going to start out, like I always do in dimensional analysis, by writing down what I'm given. I'm given 0.366 moles of NaOH. That's my starting point. The question asks me how many moles of sulfuric acid. So that's my ending point. Somewhere over here I have to end up with moles of H2SO4. Now here's what I'm going to do. Like in all factor label or dimensional analysis problems, I'm going to continue to multiply by things that I know are equal to each other, divided by each other. In other words, I'm going to multiply by 1 creatively so that I change my units. Well, a stoichiometric equivalency is my next step here. I want moles of NaOH to disappear. I want them to cancel out because I don't want that in my answer. So I'll put them down on the bottom so they can cancel with the moles of NaOH that are on the top currently. My answer, I want to have moles of H2SO4 in. So I'm going to put moles of H2SO4 on the top. And now I'm going to piece together a stoichiometric equivalency. By looking at the balanced chemical equation, I see that there's a 1 mole of H2SO4 to 2 mole NaOH ratio. 2 moles of NaOH in the context of this equation is the equivalent of 1 mole of H2SO4. So I'm just multiplying by 1. Moles cancel out. NaOH cancels out. The units I have left are the units that I want in my answer, which is just moles of H2SO4. So now the only thing that's left to do is the calculation. 0.366 times 1 divided by 2. That comes out to 0.183 moles of H2SO4. Here's another one. How many moles of water would be created when 30.0 moles of CH2 react in this equation. This is a combustion equation. Again, I start out with what I know. 30.0 moles of CH2. That's my starting point. What do I want to get from that? I want to know how many moles of H2O will be formed. Here's the conversion factor. The mole ratio that I want to use is going to have moles of CH2 on the bottom because I want that to cancel. I don't want it in my answer. In the top, I'm going to put moles of H2O because I do want that in my answer. The coefficient in front of CH2 is 2, so I put that down here. The coefficient in front of water is also 2. So 2 divided by 2 cancels. Moles of CH2 cancel. I'm left with moles of water, and the answer is 30 times 1. So it's just 30.0 moles of water. You try one. Well, here's your answer. This is the same equation that we had in the last example, but it's a different question. I'm given this information. 0.316 moles of CH2 are going to combust. What I want to know over here is how many moles of oxygen will be required to do that. Well, the conversion factor is a mole ratio, a stoichiometric equivalence. I know I want moles of CH2 to cancel, so I put that down here. I know my answer is supposed to have moles of O2 in it, so I'll put that up here so it appears in my answer. The ratio? Well, the balanced chemical equation says 3 moles of O2 for every 2 moles of CH2. Moles of CH2 now cancel, which I intended, and the answer is going to be moles of O2. Now that my units are right, I know my number will be right. So I do my calculation. 0.316 times 3 divided by 2 gives me 0.474 moles of oxygen. Here's another. Well, here's your answer. The question here is how many moles of sodium sulfate are produced from 0.366 moles of NaOH? So I write down my starting point, 0.366 moles of NaOH, that's what I'm given, and my ending point. My ending point is moles of sodium sulfate, Na2SO4. That's where I want to get. The conversion factor is a mole ratio. I want moles of NaOH to cancel, so I put that down here. I want moles of sodium sulfate to appear in my answer, so I'll put that up on top. The ratio? Well, in front of Na2SO4 is a 1. In front of NaOH is a 2. Moles of NaOH will now cancel out, leaving me with moles of Na2SO4, sodium sulfate, and that's what I want for my answer to be. When I take 0.366 and divide by 2, I come up with 0.183 moles of sodium sulfate.